Okay, I am back to the math drawing that I'm so fond of, and I accidentally put some lines in because I couldn't really help myself. But hopefully all these classes of compounds look extremely familiar to you at this point. Like, I know my functional groups. And so I hope that you can tell me how I might get from alkane to haloalkane. Cool. And how would I get from a haloalkane to an alcohol? How would I get from an alcohol to an aldehyde? It's distill. I think I spelled distill with 2 L's, but things are so British, like I forget how to spell words I double. But this is not telling me how to do it. That's telling me how I'm going to heat it. Yeah, that's what. Oh, I'm liking that better. Acidified potassium dichromate. Cool, cool. It can be. We don't. How do, sorry, what? Addition. Is this the substitution? No. There we go. Pretty disgusting. I'll take it. So we can do addition reactions. Our expectation is that if we have to write a mechanism, it's going to be to make a haloalkane, so that's why I starred that guy and didn't star the others. Is there anything else that's woefully missing? The dotted lines are because I don't think they're going to ask you about it, but here you do nucleophilic substitution with cyanide. Here you do nucleophilic substitution with ammonia. And here you do hydrogenation with platinum. Those are dotty because I think they're part of our syllabus, but like not things I expect them ever to tell me to do. Really, is anything missing? You might argue that benzene is missing. We can nitrate benzene. What's the name of that? And Audrey taught it's 50 degrees Celsius because, you know, I tried to get it wrong for you guys. Electrophilic aromatic substitution, 50 degrees, nitric acid and sulfuric acid. This is almost right. This is almost everything you have to know. Karthika, ever ahead of me, has said that there's reduction reactions we need to know. So of the 2 things we're going to talk about today, one of them is reduction. Reduction is the opposite of oxidation. And so we're going to find out that instead of going from the alcohol down, we're going to have a means to go from these things up back to the alcohol. Reagents that we're going to use are lithium aluminum hydride and sodium borohydride. So here I tend to prefer the stronger thing just to keep Elizabeth on her toes. If you want to reduce a carboxylic acid, you must use the stronger one. You must use lithium aluminum hydride. In the first step, you add lithium aluminum hydride that's dissolved in ether, and then you quote unquote work it up with some acid. I've never seen a hard question about this. I don't keep this in the lab. It's one of those things I'm low-key scared of. Yeah, I know. I shouldn't be, but I have not reduced a lot of things in my life. Like, that's my fear. Usually you use it in ether, and ether is something that turns into epoxides when it sits in there, and that's what they bring the little robots in to take out of your lab because it's a contact explosive. So I avoid the ether because we use chemicals for too long to guarantee that we wouldn't have that accident. And so I've never used the lithium aluminum hydride because I'm not sure if it's possible to use it without the ether. That's the only way I've seen them coupled. So I have no experience with this inside a high school lab. Sodium borohydride, that's a B. So if you have an aldehyde or a ketone, you can reduce it back to an alcohol with sodium borohydride. Lithium aluminum hydride will do that as well as go from that final product, the carboxylic acid, back to the hydroxyl group. So if you want that here, we're just going to make some blue arrows. And the blue arrows, I'm going to put lithium aluminum hydride. I'll write the ether. I'm not going to get a mark for it. What I expect you to be able to find in a problem is lithium aluminum hydride and sodium borohydride are reducing agents. They will reduce things back to alcohols. You can't write a balanced chemical equation because you haven't learned chapter 9. It's just a fact. There's no color change that's associated with this. So it's just it's a one-off. It's easy. Honestly, it's easy. But in that same reduction section in chapter 20, reduction is only HL. It's not a hard part of HL, but it's only HL. We learn one more reaction, and it's that we can take nitrobenzene and reduce it to phenylamine. That's one word, I just made my circle too small, phenylamine. It's also known as aniline if you've ever tried to tan leather, something I'm sure Quinn does in his free time. Aniline is a chemical that we use to tan leather. I assume that the reason this sequence is part of our curriculum is because it has some industrial applications. It's very specific, right? The reagents that we use for this are 2 steps. In the first step, you use tin and hydrochloric acid. And in the second step, you use sodium hydroxide. You will sometimes see that instead of using tin, they use zinc. And if ever there were 2 elements I wanted to kind of confuse, tin and zinc are really high up there. They look the same, you can kind of pronounce them the same. You get marks for either. Most of the time they show it with the tin. Occasionally you'll see it with the zinc. What would a metal do in a chemical reaction? What do you think the charge of zinc would become on the other side of a chemical reaction? You start with elemental zinc. It's going to be oxidized, it's going to become positive. And so because the zinc or the tin is being oxidized into that metal cation, our nitrobenzene is being reduced into phenylamine. If you want to know a little bit more detail, for now, I'm just going to do this. The first thing you make is actually not your desired product. You actually make this, which is known as phenylammonium. And in the second step, we take that phenylammonium It acts as an acid. It reacts with sodium hydroxide. I'll try to be consistent. To make water and our desired phenylamine. In chapter 9, I promise that we will come back to both the oxidation and reduction reactions to make sure that you can write them in their full glory. In chapter 20, this is really meant to be a 1 or 2 mark question that's do you know the reagents that are required to reduce nitrobenzene. So for me, this blue stuff is one idea that we haven't talked about. It's the opposite of oxidation. We see it in 2 places. We actually reverse the oxidation reactions that we worked so hard on in chapter 10. And then we have this one new step. It has 2 reagents, and we're just going to commit those to memory on a flashcard that Margaret is soon going to be famous for. When we talk more about redox, we're going to understand how to balance that chemical equation, identify exactly how things are oxidized and reduced in multiple cases. So it's just a nice way to practice and reinforce.
We need to know the lithium and the
Yes. So you need to know that lithium aluminum hydride and sodium borohydride are my 2 favorite reducing agents for aldehydes, ketones, and carboxylic acids.
and those are for.
And these 2 are for this particular reaction. I actually thought Luke was going to be here today. He was in a wheelchair yesterday.
I heard he fell off the
Oh yeah, I remember.
Okay, so this sheet has 2 sides. On the side that probably is up, it says questions on reduction reactions. Methylbutanoic acid can be reduced using lithium aluminum hydride. That's because it's a carboxylic acid. It requires lithium aluminum hydride. The organic product goes via an intermediate which cannot be isolated as it is even more readily reduced than 2-methylbutanoic acid. Identify the intermediate. So here we are with a carboxylic acid. We're going up in this picture. What do you think the intermediate is likely to be, having not been told? I assume it's the aldehyde. So while I drew this as a direct picture, I draw it as a direct picture because you can't trap this. We had that clever scheme where we distilled versus refluxed to trap this. In the reduction, that clever scheme does not seem to exist. So we're going to draw 2-methylbutanal. Easy peasy? 2-methylbutanal. What is the final product going to be? 2-methylbutanol. So we're going to go from the aldehyde to the alcohol. So if we wanted to draw those 2 products, I'm not worried about the equations again because I know you haven't learned topic 9. So balancing redox equations is not where I want to spend my time. Dude, one of the freshmen told me that like 3 of his teachers yesterday were using tais-toi. Like, why are all the teachers telling people to shut up in French? 3 like Anglophone teachers were saying tais-toi. And I was one of them. It's like, why are people saying this today? Like, because y'all are something else. I just was erasing it from my board because I was losing my patience yesterday, as you can imagine. So we had 2-methylbutanoic acid. That would be this compound. And as we reduce it, we think we're going to go through 2 steps, even if we can't capture them both. The first step is going to be making the aldehyde. So that's when you wrote down 2-methylbutanal. And then the second step is going to be making the alcohol. And that's why you wrote down 2-methylbutanol. 3-methyl. Have I miscounted? Now I'm all nervous. Caution. figured it out, Randy. I'll do the steps again, just so everyone has it perfect. I just made a little faux pas. Okay, 2-methyl butanoic acid. In the first step, it's going to be reduced to the aldehyde, 2-methyl butanal. And in the last step, it's going to be reduced to the alcohol, 2-methyl butan 1-all. I have to tell you the all is in position 1. I don't have to tell you about the aldehyde or the carboxylic acid because that is implied. God bless Karthika. Say both. Everyone's There are 4 different alcohols that are structural isomers with the molecular formula C4H10O. Draw them. Give me their names. I'm gonna get this one right. No one's gonna judge me. Everyone drawing isomers of C4H10O. How's Florida State Cowboy? Okay. Didn't know if it was like a Cowboys and Indians play, if it was their Hicks in the middle of Florida. Just Florida State has the largest program in nuclear magnetic resonance spectroscopy. Chapter 21, they make a big magnet in Florida State. Like a big magnet there in Tallahassee. Mohab, you got an isomer for me because you look bored. We can also integrate and tangent substitute. Like, I'm good with that.
Yeah, just draw like a 4C.
You have to name them, so like you can do me a solid.
I mean, I didn't really name it. I just,
You can name it now. You're nearly a grown-ass man.
I did 1 butanol.
Perfect. 1 butanol. Ramy,
Wait, 1 butanol?
how many hydrogens do we put on this? How many hydrogens do we put on this? All of them.
Yeah.
You don't like drawing hydrogens, everyone. Okay, so we got 1. Anyone have another one? 2-methyl propane 2-all. 2 more.
Wait, 2-methyl what?
2-methyl propane 2-all. So that's propane, that's a methyl, that's an all. The longest chain is propane. It has a 2-methyl propane 2-all. I love it.
We do 1 butene.
No butenes. I can't have a double bond and have all of these glorious hydrogens that Ramy and I are really enjoying drawing right now. There you go. So Amarachi said that I could make propanol with the all on the 1 position and still keep that methyl. So this is 2-methyl propane 1-all. There should be 1 more unbranched guy. Buten 2-all. We never have a singular oxygen without a charge. We put an oxygen in between 2 chains, we call it an ether. But because the question said draw the alcohols, I didn't draw the ethers. So because they limited the functional group isomers to only the alcohols, we're not trying to draw everything we can, we're just trying to draw what they asked for. Okay, so when we're looking at those, 3 of these can be prepared by reducing an aldehyde or a ketone. One of them cannot be prepared by reducing an aldehyde or the ketone. Which one of these is not like the other? One of them is probably tertiary or something. That's the one that we can't oxidize, so chances are there's nothing that we can reduce to get there. So the answer to 3 is that one, the 2-methylpropane-2-ol. 2 of these are primary. They both used to be aldehydes. So we could turn them back into aldehydes if we wanted. And one of these was secondary, so we could turn it back into a ketone. So I believe you should have butanal, butanone, and then this weird branched aldehyde that we would call 2-methylpropanal. Right? Lawful? So good? Number 3, phenylamine can be prepared by firstly refluxing nitrobenzene with a mixture of tin metal and concentrated hydrochloric acid, then reacting the organic product formed from this first step with sodium hydroxide solution. Identify the role played by the tin metal. It is the reducing agent. State the name of the intermediate organic product formed in this reaction. Phenylammonium. State the equation for the reaction of this intermediate product to sodium hydroxide to form phenylamine. You're going to add an OH and make water and phenylamine. That was on the board earlier. I'll write it again though. So I'm sort of skipping half of B. I'm not stating the half equation because again, that's a topic 9 question and I'm sensitive to the fact we haven't learned it. But when I get to part 3, it says take that product that you made, which was the phenylammonium cation, react it with sodium hydroxide, and this is just an acid-base reaction. So here's my base, here's my acid. They're going to come together to make water, sodium cations, and phenylamine. So the answer to 1 was reducing agent, the answer to 2 is the thing that's drawn on the far left, and the answer to 3 is that reaction. I saved reduction till the end because I do not think this is a big deal. Remember, I think in-thinking questions are among the hardest we've got, and I didn't find these questions particularly awful. The answer to number 2, state the name of the intermediate product. It's phenylammonium cation, or phenylammonium ion. We're not drawing the half reaction yet. We're going to do that when we get to topic 9. It's not a big deal, but we just haven't learned it together. Oh. I didn't sleep much last night. Does it show?
Not really.
I mean, I feel like you're always tired.
So they're changing the IB curriculum pretty drastically for the current sophomores. They'll have a completely different biology, chemistry, and physics class. Crazy different.
Like easier different? Or
So
harder?
instead of having like a unit on thermochemistry, the units are divided into structure and reactivity.
But they're filming all the same content?
There's no more option. They've moved some of the option topics into the core. There's only 2 papers. I don't know that you're screwed. Yes, IB itself is changing. So I'm in a class to learn how it's changing, and all of my work is due today. So I was up too late last night trying to quasi-finish it because I'm no better than you guys. The rest of it's due next Wednesday, so beware.
There's a due date for you?
Yeah, I have 3 weeks to do this course. So the first 2 weeks was the first deadline, and then the last week is the other deadline.
Are they having you learn this?
Right now, I am marking an IAA with the new rubric. So no longer is there personal engagement and communication, but analysis, conclusions, evaluations, and like methodology, but it's not called that. So there are only 4 criteria, but 3 of them are analysis, conclusions, and evaluations. So they're putting way more focus on that. But they're also going to let like that table come up with an experiment together. They just have to collect their own data.
So it's like science.
So there's a collaborative aspect to all the science IAs coming. No personal engagement. What? They change the curriculum every 7 years. Because of COVID, the lifespan has been a little bit longer than it's meant to, but that's why I always caution you when you're looking at past papers that the syllabus was different. So like one of the big changes in 2016 is they tried to up the level of the multiple choice questions. What? Yes, so if you look at truly past papers, because I'm trying to find questions that stupid Audrey hasn't already found, you know, I'll find questions sometimes that are too easy because they're too fact-based and not enough like deduce infer, that kind of level.
I like the fact-based ones.
No, it's done.
It's gone.
It's gone.
Okay.
So they had said that the class that Margaret and Karthika is in was gonna replace that. So the idea was that for that kid, they would take AA first, and then they would take that class, which has more applications second. That is not the reality that we are observing. Yes, that is one of the things they're gonna do for advanced topics.
They tried doing that. It did not work.
I mean, yeah. What? We've never offered calculus.
Never? No, didn't we the year before advanced topics and math?
We had
There
further
was
math.
one class.
We have further math.
We have further math. Further math was discrete, and we have never offered calculus.
Wait, Ivy's getting rid of math?
No, Ivy already got rid of math. There used to be a math class called Further Math. It was for people who had already finished what you now call AAHL. So
Oh my
AAHL
God.
had options in the class. You had to learn one option, but then you could learn the other 3 options, and that was called Further Math.
Yeah, and then our year they added advanced topics as a buffer to get us
Right.
to
It was not a good buffer.
It was not a good buffer.
Y'all had Martine?
Sanchez.
Sanchez. Cause they just
Those are the same person.
Oh,
I
they just
didn't.
threw the further mathematics book and they were like, yeah, teach them that. And it was like, what's Tommy's theory? Please, what is that?
Oh God. Oh God.
Okay, so on the other side of your paper, I have the unit that I most enjoy in chapter 20. It's called synthetic roots. So in synthetic roots, what you've got to do is you've got to start with some organic reactant, and you've got to end up with some organic product, and you can use essentially anything inorganic that you want. So you can use chlorine, you can use acid, you can use HCl, you can use acidified potassium dichromate, you can use tin, but you can't use like benzoic acid. I'm not sure why you would, but you get me, you can't use organic compounds. And the goal here is to start with one thing and make another. 4 is not interesting because we've done it. It's right here. This is the answer to number 4. It's not interesting. It's not asking you necessarily for mechanisms here, just for a pathway. So that's why I draw this pathway. So I'm going to have you take a minute and look at 1, 2, 3, and 5. I'll give you about 12 minutes. Well, give or take. Why are you looking at this? Roger, you can start on the board. Down with that too.
Audrey, can you pass me the board?
So it's gonna want the reactant, the product, and the conditions that you need. So sort of what's written there. So you could take a given alcohol and then write over the line H plus acidified potassium dichromate and E and end up with that molecule. So that's not a balanced chemical reaction, but it's gonna show the reactants, the products, and the conditions. So then you're gonna take the product you made, make it your reactant, and do the next step. You wanna do one together? Choose one, Mohab.
All we say is like, okay, we have 2-methyl propane, draw the line, and then I guess for this case we say like the
think I tried to put everything on the map.
Yeah, and everything's on the map. Wait, so
So we're trying to do one. Say that again, Emma.
so I would have to start from, you would have to go through one and just one.
Yeah.
From alkyl to carboxylic acid.
Okay, so I'm gonna do this and y'all are gonna mock me when I make mistakes. So we're gonna make a haloalkane, I heard.
Oh, why are we?
And now I'm gonna think about which haloalkane I wanna make. So I told you what the reactants were, what the conditions were, and I said what the mechanism was.
Oh.
But it doesn't really matter because you're just gonna get rid of it with
Right, but I need to put the chlorine on the right spot,
the, okay.
right? So I don't wanna put the chlorine here, but I could put it anywhere else.
Okay.
I'm trying to do question one. I don't know if I've done something stupid yet or not.
Oh, it's okay.
So I knew that I wanted the chlorine on the end because I am hoping that I could get a carboxylic acid there. So I'm gonna take that chlorine and what am I gonna do to it? It's a primary, so it's probably gonna be SN2, but I'm not really responsible for that. Okay, so we did nucleophilic substitution, we replaced the chlorine with the hydroxyl. What did we do last?
Oh, yeah, straight to carboxylic acid.
Yeah. It was fun. The mechanisms? Arrow pushing or yields arrows?
The curly arrow.
No mechanism, it doesn't ask for one, right? It says for each step specify the reagents and necessary conditions and write an equation. So that's what I've done. That's why I have the products in parentheses. I'm not really sure if I'm gonna get a mark for that. It's not an IB question, so it's not really well stated. I feel like an equation should be balanced on the whole. Does it make more sense what I'm trying to go for?
Yeah.
Okay, try number 2, friendly party animal. Roll on the loop. Always ions, like resistance of that. Concentrated phosphoric acid is who has an idea for two? Two of you? Three of you? Let's go, Amara. Yes.
So the example of reduction you put on the board with the nitro, the benzene,
Yes.
are the, like, it's the intermediate and like the stuff, it's like phenol ammonia, but is that really specific to nitrobenzene?
Phenylammonium is that what, nitrobenzene?
Like, it's the intermediate, right, for the reduction,
I don't
but
think
is
I'm
that
the right
really
person.
like, is it really
Okay.
phenol ammonia versus the nitrobenzene reaction? So then I want you to know what the, reactants for like other reactions. Is it like
So-
water, saline?
You wouldn't. Like, we memorize the nitration of benzene and we memorize the reduction of the nitrated benzene as just some random, could be up to 6 marks on this test, garbage that does not seem to fit into our, there's a pathway for electrons to flow through reactions and you're able to make inferences about how another reaction should go. Like, it's just a straight one-off reaction.
So if you like show me the arrow like you did there with the most right reduction.
Yeah. But in chapter 9, we'll learn how to balance that equation because that is a question they could ask. They're gonna ask it with regards to oxidation and reduction, not with regards to this. Do we need más tiempo or are we ready to talk about 2?
30 seconds.
Yes, sir? Does this molecule exist as cis and trans? I'm gonna sneeze, that's the problem I'm having. Like,
But can the bond?
so let's think about what we got going out around that double bond. I felt like it's something I didn't do a good job with you, Steve. That would be the same molecule, correct? Drawn a little more neatly, like I knew what the molecule was. I want you to imagine that I flip around this carbon. That would be the difference between cis and trans. When you look at these two molecules, what might you notice? They're flipped. If we just took this molecule and flipped it 180 degrees, we would have this molecule there the same. If we have a carbon that has the same thing on it, there's no such thing as cis and trans. You have to have two different things on both carbons to be able to use cis, trans, E, and C. I felt like I left that out of last class.
So if that second carbon had something else.
Right, so if we had a chlorine here, then we have different things on each carbon.
Yeah.
That is, this is different from this, and this is different from this. The two carbons don't care about each other. Then we could talk about cis and trans. But because that single carbon has two hydrogens on it, there's no such thing as cis and trans. Yes? Yes.
That's for E and C, right?
That's for E and C and cis and trans. But there's only one molecule here. Like you can't, the two things are identical. Okay, in the first step, this molecule was supposed to react with HBr. I'm not sure that that's the path y'all would have taken. Was there a faster way to get to an alcohol? So I could have done alkene to alcohol using concentrated phosphoric acid and heat, but they told me to do this. And so where does the bromine add? Okay.
All electrons and 2 neutrons. How'd I do? Kicked out.
How are you?
I'm good, how about you?
Okay.
I was up here, so figured I'd say a lot. I'm on trip for some
Who
time.
wrote the football paragraph?
Me.
There's a lot.
Yeah,
Dense.
I had to miss the first half. Yeah. So I had to catch up on what happened.
See. Okay, so I heard that if we are using Markovnikov's rule because we have an asymmetric alkene and an asymmetric HBr, that the hydrogen is going to add to the carbon with more hydrogens, or the bromine is going to go in that right position. So this product should be a bromine here, a hydrogen here, and the rest of the stuff still bonded.
Please give an explanation. Because like I just put.
In this problem?
Yeah, because I just
Absolutely
put
not.
it to the second C because we were making.
Yep. Here, I'm just trying to admit you have a test coming up and remind you of some stuff. So that's all I would write, that's all you wrote, I presume. How do we turn this into an alcohol? I'm going to do nucleophilic substitution. This is a secondary guy, it could be SN1 or SN2. We don't care. Is this compound chiral? It is. So the products would be different depending on which one we did, but there's no commentary about that in this problem. Elizabeth, I'm not sure what your question was. Chiral means handed. It means like it's a molecule like your left and right hand, which are different from each other. It interacts with other things that are handed differently. So if I try to shake, we're going to shake hands. I'm going to shake your wrong hand. Oh my God, this does not work. We cannot shake hands. Both hands are handed. The only way this makes sense is if we actually shake hands properly. The next thing we're going to do is we're going to take this and we're going to turn it into a ketone with acidified potassium dichromate.
Is there no everyone matter?
What?
No.
Oxidize? What did I do badly? That I didn't write separate reactions? Bueno? It doesn't matter. There's only one product, so you can kind of do what you want. Refluxing is easier than distilling, but since you're only going to get one product, we typically just don't. That's how you would, so if Karth goes in the lab doing it, she would use reflux, but the only thing you need is heat. I think heat traditionally implies reflux in organic chemistry. Okay, we're gonna do 3 and then we're gonna be done with this activity so we can do something else. Don't rush.
So the first step is addition.
Okay, sure, let's name them, sorry. This is electrophilic addition. Second one is nucleophilic substitution. It's not a mechanism, it's just the oxidation of an alcohol. So last but not least, give 3 a try. You're trying to make an ester.
If carbon doesn't get it, then I think we're all screwed.
3 is in, we've done 1 and 2. I'm not sure I have the patience for 5. We're doing great. Is this
so many.
Yes. I saw it.
So one of the tools that I feel like you're kind of developing on your own is the notion of retrosynthesis. The notion of retrosynthesis is holy moly, I need to make an ester. How do I make an ester? There's only one path to ester. The path to ester takes a reaction, a condensation reaction between alcohol and carboxylic acid. So if I'm going to make an ester, I have to have an alcohol and a carboxylic acid. So how could I get there? So we're an aldehyde, so is it possible for an aldehyde to make an alcohol?
So we just go back to alcohol.
Is it possible for an aldehyde to make a carboxylic acid?
Oh.
Yeah, you just teach that.
How do you
You have to react it with alcohol. So what I'm hearing is that we're gonna take this aldehyde that we start with and we're gonna separate it into two containers. One of those containers we're gonna oxidize to a carboxylic acid. The other container we're gonna reduce to an alcohol. And we're gonna take our alcohol and our carboxylic acid, mix them together, and make ester. So you're gonna use potassium dichromate to take the aldehyde and turn it into a carboxylic acid. And you're gonna use lithium aluminum hydride to take the aldehyde and turn it into an alcohol. Reflux, but it doesn't matter, heat is fine. That's correct, we need both. So there are two arrows going to ester because it's a condensation reaction between carboxylic acid and alcohol. That's why there are two lines that go to amide. It's a condensation reaction between carboxylic acid and amide. That is what you were doing in biology today. First period biology, they were writing that on a piece of paper while they were working on using amylase to cut glucose, amylose.
Oh.
Amylase to use amylose into glucose or maltose or something.
Have you seen like the thing that we got?
No.
digestion. It was very unpleasing.
They were drawing dipeptides. They were not making bags of gross digested food.
We were. Before that, we were.
And then the bag, while we were squishing stuff, it started leaking. So we got like all over.
It was like
I can
dripping,
still smell it.
and it was like,
It smelled like crushed cracks.
I'm so nauseating.
Wait, what did you do in biology?
no, and then initially, like, Shrey wasn't putting it on top of, like, the cup, so it was, like, kind of hitting the edge of the cup.
It didn't make me want to vomit. It was a good day. Apparently I have like a low vomit.
What would you need for the condensation reaction?
What would I need for which? Acid, you need H+. Oh, so you need this and this. You're missing two H's. So these two things come together. Okay, so I'm gonna write 3 down because I'm not sure that.
No, we don't understand.
No. But don't you go for what happened? Oh, you okay? I will be. Okay, that's good.
Yes. that is what I wrote down for 3. So I took my aldehyde and I separated it into 2 containers. Some of the aldehyde I oxidized to make carboxylic acid. The other half of the aldehyde I reduced to make alcohol. Then I took the carboxylic acid and the alcohol, and in the presence of acid, they undergo a condensation reaction that makes my coupe, that makes my ester.
Are we supposed to like memorize that?
Yeah. What? Acid. Are we supposed to memorize? Yes, because it's in my roadmap. So we started here with aldehyde, and I'm saying I took some of it to carboxylic acid and some of it to alcohol, and then these 2 things come together to make ester. I feel like my picture makes more sense to at least one kid.
Why can't we use the NaBH4?
You can. I always use lithium aluminum hydride.
Okay, because
I'm simple-minded on it.
so we can use either of them if it's an aldehyde.
Yes, you can.
Sophia, where do you put
How
the
do I
videos?
draw an aldehyde? Joe?
Where do you put the videos?
I put them on. Did I not? Do you have Instagram?
I do, but I don't use it much. I don't use it much. What is it?
I'll just send the link.
Ethanol aldehyde. We're good. I was scared. I was writing CH2 for methyl groups over and over again. Because those are the 2 ingredients to make an ester. If you think about your biology class, how do you make a triglyceride? What? You cut the damn paper you posted on the cupboard.
We just do that.
We didn't do that. We did the digestion.
What did we last year?
This is last year, maybe.
Ammonia. No, we didn't.
Okay, so if you went back in time for a moment, you might recall that if you take glycerol, which the adults in the room call 1,2,3-propane triol, and you condensed it with a fatty acid, what would you get? So the Q and the OH come together to make a coupe. That's how we made polyesters the day we were making condensation polymers. Coupe. It takes a Q and an alcohol. Yes, I know the story actually. See, there are reasons that we pronounce some of these words and not others. So apparently Aditi made up her own. Like I have chose and coops, but I do not have cock because it's not a nice word to say. Or Aditi was trying to say she had either an ether or a ketone. I'm not sure which.
Explain it to Ruby in math. It was in the middle of doing the chain rule, and I was like,
Everyone's dead silent. It just said it out loud, so everyone just thinks like it's like
Don't write on it. She hide hers already?
So are these like previous tests where the multiple choice questions are simple, or is this realistic to our syllabus?
So these are meant to be realistic to your syllabus. On the whole, I find in thinking harder,
Oh,
but I thought these were pretty reasonable.
yeah, like, okay, because I can answer this, but I didn't know it was like
No, it is not meant to, like, it's meant to be hard, but I think it is realistic. Oh, you already have this?
yeah. You
The International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Okay, you're gonna try to run through that multiple choice. Lithium aluminum hydride. LiAlH4. That's my favorite. You need to know that NaBH4 will do it also. BH4. I think if they give you the choice, you can always choose to write this one, but you have to recognize that in a multiple choice answer. It's like this. What is wrong? alone, that's not part of the chain, right? 5 as a methyl group. Yes. Sophia's got one down.
I'm going
19
down.
to go.
Oh, I thought you said like I'm going down, like going down in flames.
Not at all. I was trying to say like one down, 20 to go. You have one right. You ready? I really don't talk trash about you ever.
What are these white things?
How bad are you? I'm telling her no, there's no formula. That's 1, 2, 3, 4, 5. That's 3 methyl and 6. That's also 3 methyl.
Here. I forgot what a lot of stuff meant, to be honest. It's the same?
The year is not
Almost same. Same.
Australia before, yeah.
Homologous chromosomes are like.
Yeah, that's it.
You put 3, you put 5.
Chromosomes of the
Here, I'm about to find out.
alleles in
You're
similar
confused.
places.
I haven't done it, so I'm doing it real
Fuck.
time.
Yeah.
Oh, found it.
Oh, the series related by a common structural
There are
unit.
5 people.
Yes, that's what it was.
There's no butene.
Okay.
Then what you get for 2?
I didn't didn't get anything so far. We were researching homologous chromosomes and series.
Yeah. Oh wait. Wait. What's the difference between Well, I meant. I thought that was a how, but I might have forgot.
Will there be more lecture after this?
No, I would like you to complete this now.
Okay.
Actually, you might be right because the